Fine. Chapter 2, Structure of Atom. Okay. So first of all, we are talking about the atomic models. Okay. So in the atomic models, we are having first uh, Thomson model of atom, in which J.J. Thomson has, which is given by proposed by J.J. Thomson in the year 1898. So he said that according to his model, the atom proposed a spherical shape. Okay,
Yeah.
atom proposes spherical in shape in which all positive charges are distributed everywhere and the electrons are embedded into it, just like this. And his model is also known as what plum boarding model. So this is everywhere, this is the positive charge and these are what electrons.
Yeah. Okay.
And everywhere is the positive charge. The another model after that, but that was not true, because if it is possible, then where it is, there is a very big force in the center, that is our nucleus. Because of that reason, this model has been failed. The second model was given by our Rutherford, sir.
Reason for the failure.
What, Victor?
Can you repeat the reason for the failure?
Because we know that the nucleus is at the center, electron is distributed, electron is embedded, but there is a very big force. According to him, the positive charge is everywhere, everywhere in the blank space. The blank space is known as what? Positive charge, in which he said that the electrons are embedded in it, but it is not true. The positive charge at the center. If it is like that, then high, it means that everywhere the negative charge will repel, because positive and negative repel each other. But it's not like that. Okay, so that was corrected by
So
our
what happens
Rutherford.
if it,
Nothing happens. The new model has been declared. That is Rutherford's nuclear model.
they would have repelled, right? So what would have happened then if his atom was true? I mean, like if his model was true, like the positive charges are embedded in the negative sphere. So sorry, electric negative charges are embedded in the positive sphere. So they'll repel, right? So what will happen during that repulsion? I mean, like many of the
It
like
means
all
all
the
the alpha particles. See,
mm,
if the alpha particles will go, it will always repel. But I have already shown you one Rutherford Goldfoil experiment in which a lot of alpha particles are going. In fact, crore alpha particles are going, and hardly very few alpha particles are bouncing back, because at the center there is a positive charge which helps to repel the alpha particle, and it is very few alpha particles are repelling, because electrons are everywhere in the gold foil. That's the reason the new model has been declared, that is known as Rutherford nuclear model. And his students Hans Geiger and Ernest Madsen has proposed this model with the gold foil experiment, that yes, there is the electrons are distributed everywhere in its own orbit, but he said that the electrons are everywhere. He said that these are the alpha particle beams. This, he said these are the alpha particle beams. Okay, and very few deflection, it means very few deflection takes place. Because they they come near the nucleus. And in which only 1 and 2 alpha particles bounces back with 180 degree.
Like bouncing like a ball. Oh.
Yes, because when the alpha particle comes, very few will go back.
Why, ma'am?
Because of repulsive force. So that will go along the straight path. And if it is like here, it will go with this way. If it is like here, it will go with this way. And if it is far away from the nucleus, it will go straight line. So very few, it means our nucleus is so small that only 1 or 2 alpha particles bounces back. Okay?
It's also because of deflection. I mean, like because of repulsion, the curve. That.
Or the deflection takes place now, but very few bounces back because charges repel each other. Correct? And the more details why it is happening and all we will study in class 12th physics.
Okay.
In class 12 physics also you are having these things in which if you want closest distance to closest approach and all is this formulas are also there. Okay, that you will study in class 12th physics. In chemistry you have to study only this thing, but understand the concept that only very few alpha particles bounces back with 180 degree. Okay, and the drawback was that according to his model, first you understand, according to his model, he said that the positive charges and the most of the mass of the atom are concentrated at the center. That is, he has proposed the nucleus, which is true. Okay, but he also said that the nucleus is surrounded by the electrons. Okay, which is moving towards the nucleus, and the electron, which is known as, he has said that this is the orbit. Okay, so according to his theory, nucleus is correct, orbit is correct, but he says that the electrons and the nucleus are held together by electrostatic force of attraction. Because of that reason, the electron rotates in its orbit and then it falls in the nucleus. If this thing happened, then how can a body, when a body is moving in an orbit, undergoes acceleration? So electrons in a nuclear model is under acceleration, which is not like that. Okay, all the electrons are moving in its fixed orbit with a fixed quantity, which we have studied in K, L, M and shell. That the first orbit, which is K, has 2 electrons, second orbit has 8 electrons. Every electrons are fixed, which has been improved after coming the next model. Is that clear?
Ma'am, so like the orbit also, he discovered the orbits, right?
He discovered the orbit, but according to him, the electron is revolving and accelerating in its orbit, and because of the opposite charges, the electron comes and goes into the nucleus. It falls in the nucleus. It means there is a loss of electron.
2 and square is 2 and square is given by him of Niels Bohr.
What, bacha?
2 and square, ma'am. The capacity of holding an electron.
No. He doesn't say.
Then that was said by.
What?
Then that was said by. Then that was that said by Niels Bohr.
Yes, obviously the next model is our Bohr's model.
So he said only it is revolving in a fixed axis in accelerated motion, namely K, L, and M. That's it, right?
No, and he said this one also, that That is the next one. Okay, let's start the next model. So that was the drawback of Rutherford.
He only discovered the orbitals and named K, L, and M.
Yes,
Correct.
correct.
Okay. Okay.
Rutherford said about the nucleus, he discovered the nucleus, and he said about the orbit also. The orbit word
Okay.
was given by our Rutherford sir. Okay. Now Niels
Okay.
Bohr,
Okay.
Bohr's model.
Okay.
So according to our Bohr sir, he said that electrons. Okay, this is very improved model. He said that wave nature of electromagnetic radiation and another particle nature of electromagnetic radiation. Okay, so according to his wave nature of electromagnetic radiation, he says that this was forwarded by our James Clerk Maxwell in the year 1870. So according to he has given the explanation about the interaction between the charged bodies and the behavior of electrical and magnetic fields on macroscopic level. Okay, so
I didn't understand.
see, electromagnetic wave. Okay, I am writing that one also. Electromagnetic wave theory was given by our James Clerk Maxwell in year 1870. Okay, this theory was given by our Maxwell sir, James Maxwell sir. Okay, he explained that the interaction between the charged bodies and the behavior of electrical pulses or maybe magnetical pulses, that is opposite attract, like charges repel because of magnetic field, all that is at the macroscopic level. Just like if you are putting two bar magnets of same charges, they repel each other, opposite charges
Hmm.
attract each other, that is in the macroscopic level. Okay, not microscopic level. Fine. So when these
Hmm.
electrical charges moves under acceleration, alternating electrical and magnetic fields are generating and transmitted in the form of a wave, which is known as what? Electromagnetic waves. Because we already know wherever there is an electric field, suppose these are the positive charges, where it produces an electric field, right? So wherever there is an electric field, if in a circuit lot of protons are moving, in a closed circuit, lot of protons are moving. So it produces what? Electricity. Correct? So whenever there is a
How, man?
in a closed circuit, if they are, it is connected with a
No, no,
battery.
no, no. I'm asking about like to magnetic field, it won't produce electricity, right?
See, wherever there is a electric field, there is a magnetic field. This magnetism is known as what?
Yeah.
Repulsive
So,
force.
but negative, I mean, like the magnetic fields won't discover the electric field, right? No, ma'am. Like as the presence of the electricity, we are getting the magnetic wave, right? I mean, like the electromagnetic is produced. So in the same way, if there is a magnetic medium, we won't get the electric medium, right?
So it will get that you will study in EMF in class 12. That is known as EMI, electromagnetic induction. That is current produced. That is EMI, and the voltage potential difference is known as EMF. You will study in class 12 physics. It is produced.
So what is his theory then?
These things are
James.
that it is that if there is a magnetic field, electric field will able to produce, and if there is an electric field, magnetic field will able to produce. Okay, in the electric field we are now saying as a I, and magnetic field as known as B. And when there is a magnetic field and current is produced, that is known as EMI, and the potential difference is known as EMF. And in a current, the potential difference is known as voltage, and current is known as I, and magnetic field is denoted by B. Okay, so from the current, magnetic field is producing, and here because of a magnetic field, electric field is producing, that is known as EMI, and the
So that
potential
is his
difference
theory.
is EMF.
So is that James Clark theory?
This is not, yeah, this is our Maxwell's theory.
So then what does that have to do with the
Just
Bohr's
like in
model
your
of effect?
practical life example, when you switch off your fan still rotates for a certain period of time because of EMI, and EMF produced in that point.
EMR.
Correct. In the coil,
What
we
is
are having,
what is
in a fan, we
EMR?
are having coil in a form of a toroid. This is physics, bacha, that you will study in class 12. So, in a fan, we are having a toroid in shape, that solenoid. Okay. And because of electric field, this become magnetized and produces a EMI current. And because of that reason, when we switch off the fan, still the fans are rotating unless and until this EMI vanishes.
But they said it's friction.
What? Friction is everywhere. Friction
Then
is,
EMR.
why you are connecting friction with current? Friction is everywhere. Because of that reason, if you are a laptop using your laptop for 2 hours or 3 hours, current is heat is producing. That is the drawback of the current. Friction drawback current everywhere. There is a friction is there. In every field there is a friction. So don't connect the friction with the current. It's a different thing, Jay. Don't focus on class 12 syllabus. Otherwise, you will get totally confused. Okay,
Okay.
fine. When you come to class 12, you will understand because these are very, very simple subject. Very simple topics are there. Because this is a very big topic. If I go to this topic, then chemistry will lag. So better don't focus right now. Come to class 12. Then we will do this numericals also. Though it is very simple. It's not so difficult. When you understand the concept, you will say, ah, that's the concept was there. It's so simple. So, according to wave nature, every particle is having a wave nature. Whenever the particle is of the maybe of protons or electrons, whenever the particle is moving, whenever these protons, electrons especially, whenever the electron is moving, they always form a wave in nature, which is having a wavelength. Okay, so the wavelength is denoted by this lambda, right? There is a wave
Hmm.
number. So these things are Nikki wave motion. So in wave motion, we will study the characteristics of wave in which we are having a wavelength lambda. Frequency is denoted by mu. Okay, and velocity is denoted by c, and wave number is denoted by mu dash. This is your wave number. This is your speed of light. This is your frequency. and this is your wavelength. So wavelength is what?
Length between two crest or trough.
Correct. The length between the consecutive crest or consecutive trough. This is your crest and this is your trough. REST. That is your wavelength. Frequency is what? How many waves can able to pass through 1 second? In 1 second, how many waves are passing? That is your frequency. Okay? If the waves are too much, it means it has a high frequency. If the wave is like this, it means it is having a low frequency. Similarly, speed of light in our vacuum is how much? 3 into 10 to the power 8 meter per second. And wave number is what? Wave number is what?
1 by frequency. Sorry.
So,
1 by
number of wavelengths per unit length.
Yeah.
Number of wavelength per unit length. So the formulas will be
1 by lambda.
yes. So formula will be C is equals to lambda into mu. Mu is equals to C upon lambda. Mu bar यानी कि wave number is equals to 1 upon lambda. So mu is equals to C mu bar. So this is the equation between frequency, speed of light and wave number.
How much?
This is the equation, bacha.
No, like is this the derived one?
Yeah, this is a derived one. That
Oh,
C is equals
oh.
to lambda mu. Mu is equals to C upon lambda. Wave number is equals to number of wavelength per unit length. So mu bar यानी कि wave number is equals to 1 upon lambda. This is the formula of wave number. So mu is equals to यानी कि frequency is equals to speed of light into wave number.
That one I'm asking how.
This is the formula.
You said then it's derived one.
No, this is the formula.
Okay, wait a minute. C is equal to lambda.
And we know that electrical wave and magnetic waves both are perpendicular to each other, and their direction of propagation is also same.